Hello, my name is Ian Watson, and I'm the Executive Director of the American Membrane Technology Association, fondly referred to as AMTA. This is a continuation of our chats with the pioneers, in which we are trying to record for posterity, or maybe longer, the efforts of the early pioneers in the development of membrane technology. AMTA is a technical association that advocates the use of membrane technology for water treatment, ranging from wastewater reclamation and reuse to seawater desalination. The heart of the technology is the membrane. About 2.5 years ago, the board of directors of AMTA decided that we should make an effort to interview as many of the early pioneers in the development of this technology, not only the membrane, but also the membrane systems that came along with it, as a way of preserving the history of this technology. The roots of this technology are in the United States, and specifically in Southern California. And many of the people who worked in the early days live in and around the San Diego area. AMTA's intent is to post segments of these interviews or chats on our website so that the upcoming generation of engineers and scientists understand what went into the development of this technology and its use throughout the world today. With me at the moment I have Mr. Peter Eriksson, Mr. Mac Jawar, and Mr. Kurt Elwell.
Hello.
All three have been involved in the RO business for many years in somewhat different capacities, some paralleling some of our previous interviewees and some doing other things. So what I'd like to do is to start by asking you to describe, if you would, your first involvement in reverse osmosis, what you were doing before that, if anything, and just tell us about your career up to this point. So Kurt, why don't we start with you?
Basically, right out of high school, 72, I was working at a boatyard and there was an opening at Roga, as Fluid Systems now, I guess everybody knows. Dick Sudak actually hired me, and I began with Jerry Poole building systems, early 72s. After that, about 6 months, I started working in research and development under Seymour Crimmon with Rick Leeson and Rich Stackhouse. We started developing different equipment and developing the elements, better elements. Then we started, that's when they were having steel vessels, pressure vessels. We hired Peter Darby, and we got in to start doing fiberglass pressure vessels. And basically, I've been involved in building reverse osmosis systems and running pilots, starting up systems until present day today.
Good. You worked for Charlie Hull for a while?
I actually helped Charlie Hull start his business, and worked for him for about 2 or 3 years. And after Charlie, I helped a lot of companies start. In fact, I might even helped you build your first systems.
You made a couple of systems by me.
Yeah. Then you did a lot of UV, and you go, hey, let's put your UV on ROs, and now you're building big systems yourself.
Yeah.
But basically, I started water products research and developed different products and built a lot of systems for all kinds of different companies, and all the basically service systems for hydronautics, fluid systems, pilots, Culligan, Sparklets, just numerous companies.
Good.
I did everything for membrane systems until they were bought by H2O. At that time, I started working for Torre, and that's where I am today.
Good. Mac, how about you?
Well, getting into membrane business was sort of a coincidence. During my final year, I had an opportunity to work for a professor at University of Missouri who was working on an innovative process how to make membrane. And I wanted a good grade, so I joined his group, did some work, and got out. And after my graduation, I went to work for Fairbanks Morse, which had a water treatment division. Basically, it was thermal technology, if you will, vacuum freezing, vapor compression process. So I wound up working for them for a couple of years, and during that time, I was appointed as resident manager for one of their projects in Riceville Beach, North Carolina, using VFEC project. And during that project, again, I got exposed to membrane and went to work indirectly for OSW as resident manager for Yuma desalting facility. I was the first one to go out and investigate Colorado River and different membrane processes. And thereafter, for about 3 years, I was resident manager for Roswell Test Facility. That's when I came across fluid system, and they offered me an application engineering job in the marketing department. And I thought that was a great opportunity to get into the industry, so I moved to San Diego. And with fluid system, I was there 73 through 78, and got through various promotions and rose to the rank. And then I decided that there was a need for somebody like me, in the outside world as a freelance consultant. So I left fluid system and started my own work. And since that time, I have been doing on and off, different types of membrane separation processes, including microfiltration, ultrafiltration, RO, chemical recovery. We've done various projects. And in 1985, I started my own company called Inaqua, and I'm still with Inaqua. And we are now part of a larger group called Grundfos.
Just a little bit bigger.
A little bit bigger, quite bigger. So
Good. Now, Wrightsville Beach was one of the Office of Saline Water's test facilities
that is correct.
in North Carolina.
So was Yuma Test Facility.
Right.
So was
So it was Roswell.
Roswell Test
Yeah.
Facility.
Now,
So
at Roswell, did you know Hob McPherson?
of course,
Yeah.
I hired him.
Ah, you hired him.
Yes,
That's not
I
the
did.
way he told it. I think he told us he hired you.
Well, he was the boss. What can I say? But
Good. Good.
we were looking for young professionals, to come into the test facility, because at any given time we would have somewhere between 20 to 25 different membrane configuration equipment, for testing purposes. Roswell had Roswell test facility was very unique. We could test water from 500 ppm up to 8,000, 16,000 ppm.
Right.
And different types of equipment were employed, on different types of water. We would blend different kinds of water, do all kinds of experiments just to find out how the membranes would behave.
And you had some of the early prototypes there, like the Dow
Yes,
permeators.
Yes.
And
Dow permeators, I still
some-
remember, Peter's cohort, Hank Mahan.
Mhm.
You remember him?
No, I don't.
He used to work out of Walnut Creek facility.
Yeah, because it's not
Yeah.
the abort Filmtech in was it?
Oh, okay,
85
yeah,
or
that's
something.
right,
So
Yeah.
I don't think they went
Yeah.
to Midland.
who
Right.
was the guy? I remember Sharon Whipple.
Yes?
Yeah. Yeah, she was there. And who was the guy that was the head of that group in Dow? Forget. I met him several times at Cape Coral when they first put that plant in, which was Dow's.
Most of my contact in those days was with Hank Mahan.
Yeah.
That's all.
Okay. Okay. And Peter, you started in Sweden doing some membrane research before you came to the United States.
That's right. When I finished my master degree in chemical engineering, still I felt I didn't know much about mass transfer. There was much more I wanted to learn. So that was suitable. I wanted to start something with membranes at that Department of Chemical Engineering. So I decided to start it. And so it was mostly for not making membrane, but applications. And what we used, or I used mainly, it was either a plate and frame module. The DDS, a Danish company, were close by. They made membranes and these plate and frame systems. And then Pearson Candy in England, they used tubular systems.
Mhm.
So I used plate and frames and tubular systems, and also of course this normal Erikson cell and Berghoff cell for lab testing, and a few field tests. Not so much in RO, because back then they only had cellulose acetate membranes, and they never worked out very well when I tested them anyway. So this was not normal water application, it was more wastewaters and different process solutions I worked on. And at one time, I remember I met someone from Ajax.
Ajax
He described here
International.
the spiral bond elements. I'd never seen them before. So I said, okay, why not getting one like a 2.5 inch by 14 inch long element just to see. But then there's a cost for it, and a cost for the housing. And I thought, housing, we had a good shop at university. They can make one. So can you please send me a drawing? Or how we can make it ourselves. And got the drawing, looked at it, didn't understand at all. I gave it to the manager in the workshop. Oh yes, I can make this. He made something. I get the element. There was no way you could get it to fit together. So I never used that element. But then later, I got an invitation to present a paper here in Boston. I think it was 1980. It was the Bill Icahn. Still, I don't know why he sent me that to ask, but I said, fine. My first time to US, and it was quite different compared to Europe, in my opinion. So I was like impressed, and it was so much difference. So I visited some companies in the Boston area, Millipore, Ebcor, and one or two more. And then went to Chicago, Aquachem, and went to Wisconsin here, the Appleton, here, the Pulp and Paper Institute back down there. And then to Minneapolis area, to Osmonics and Filmtech. Then in 1980, Filmtech had 16 employees. It was a small company. Had a 12-inch machine, oral machine, membrane machine. And then after about a year or so, then the Filmtech Roy Larsson and Gene Eriksson, they went to Europe maybe once, twice, 3 times a year for different things. And most of the time they visited me at the university. And then they asked me, I was in 81 here, if I want to come and join them at Filmtech. And after some thinking, I said, why not? I like it over there. So I came there in winter, 82. I remember landed in Chicago airport. It was a gale. It was very cold. And so people out there in a big clothing and covered all over. And of course it was even worse in Minneapolis than I came at the airport. But it was okay. And back then there were about 40 people at Filmtech. They have learned to roll elements, mostly small elements. The biggest was 4-inch, 40-40. Still a 12-inch wide machine. You splice the membrane, make 12-inch membrane, and then you put the tape, so you get 40-inch long element. And it worked. I'm sure it gave a bit higher pressure drop than not splicing, but otherwise it was fine. And I remember that I was the first person there who knew how to design systems, so I had an idea how to do it anyway. The other were making the membrane and what needed, and then they wanted someone who can tell our customers how to use these elements. And of course back then, if you design a system, you use a piece of paper and a pencil, and write down equations and figure out here what pressure do you need and all these things. And of course that was tiresome. So the first thing I did was to go and buy here a calculator. It's a radio check TRS-80, something like that, made by the KCO shop in Japan. We have 1450 steps you can program. So you have each character is one step. You have 1450 characters you can put in. So I could make a program for one station system, one stage. I couldn't do not enough for 2 stages, but 1 stage and at a time. So it was a good time. So I came there, film tech, had a good time, and learned about the elements, by one elements, how to make them, and so on. And then Daw, after a few years, Daw bought film tech. A little bit different, because now suddenly the headquarters were somewhere else. So now it was less control, it didn't have the contact, so it was like I slowly moved away, and then it was in '94 they needed to get rid of almost all R&D, because Dow was trying, invest a lot of money for the whole membrane business, MF, UF, and all of it. And then in '94 there was some type of low point, they lost money and so on, said, okay, we'll shut down all this activity. So I was one of the people had to go. So I had to move to California.
That was
But
tough.
it was great. That was great.
From Minneapolis to California is not bad.
It was a good thing. So started that desalination system for Don Bray. And it was fun again, because it was a small company, small, but at least one company, everything was together. Of course, later Osmonics bought diesel, and then GE bought Osmonics. So now I'm in a big group again.
One of the themes that has run through all of our interviews so far is how important Roger and Fluid Systems was to the industry as a whole. Because with the exception of Peter, almost everybody that's involved moved through Fluid Systems or Roger at one time or another.
That is correct.
And I'll ask Mac, in your time there, did you feel that you were leading the pack in terms of membrane technology?
Oh, absolutely. No question about it.
You weren't worried about Hydronautics or those
Absolutely
guys
not.
in Minneapolis? Or?
Absolutely not. They were not even on our radar.
That's good. That's good. You worked on some of the big systems that were built.
Yes, I
Orange
did.
County Water District.
I was not involved in Orange County
You were not,
District,
huh?
but I did build the first municipal wastewater system for Kirkwood Meadows.
Mhm.
Then got involved with EPA and built the Escondido demonstration plant,
Mhm.
which eventually moved to San Diego Stadium, I
Mhm.
believe somewhere around there. And then
Jim Kruger
Sa-
was telling
Sa-
us about that.
San
He said
Diego
that
Country Estate.
it operated at the stadium for many years.
Yes, many years.
Yeah.
Yes.
Yeah.
Yeah. Did a lot of work on wastewater projects such as textile, municipal wastewater.
Did you
And,
do any work in Florida?
As a matter of fact, I was Eastern Regional Manager, and I managed Florida for 2 years
Mhm.
after Randy had relinquished that duty to me.
Right. Right.
So
Right.
I did that. And I also monitored our international distributor, Ajax International. So I used to have dual purpose role,
Mhm.
the OEM sales manager as well as international sales.
Yeah.
So
How did Kurt? How did it come about that somebody suddenly decided that FRP was a much better material for the pressure vessel than steel?
Yeah, I'm not sure how it actually all came about. Rick Leeson was involved in that. I did all the prototype testing and building and blowing things up at at General Atomic, and they had a pit there. We actually put strain gauges on the fiberglass outer lay. You can measure, the cross diagonal, and you can measure the length as it gets pressurized. And you can watch this thing, and you can read numbers, and okay, the vessel's growing, and pretty soon it would explode in this big pit. And we did a lot of that kind of stuff, but they were involved in changing all the steel vessels down in Florida to fiberglass right on site. They took the steel vessels and some of the swamplands down there in the Everglades, they took those steel pipes and put the houses on the steel pipes. To this day, I think you go down Card Sound Road and you can see those houses
They
floating.
use them as pilings?
Yeah, the pilings, they use the vessels.
Yeah.
There's a guy down there used to, Cotton Williams, I don't know if anybody
Yes, Cotton Williams,
He was one of the old
Yeah.
service guys down in
He was
Florida.
at Ocean Reef, he used to take care of
That-
Ocean Reef project.
That was the place that we actually converted, and
Yeah.
from there on, everything became fiberglass.
Yeah.
That's when Pete and I actually left the company, and I helped Pete start his business. Actually interviewed Pete down at Fluid Systems or Roga back then, and I go, yeah, I like this guy. Let's get him on. So he
Yeah,
started.
we were commenting on Pete's resume, the first few years of his career, it was like a job a year.
Oh yeah.
You apply for a job, they look at that and say, well, this guy's not going to be here very long. And actually, he wasn't there very long at Fluid
No,
Systems.
he wasn't.
Yeah.
He wasn't. We went off in National City and started making our own vessels. And then I got to the point, well, this is kind of boring for me. I mean, it was fun, of course, but I like doing the system part. So
Yeah, and Fluid Systems went out of the systems business.
Correct.
Yeah.
correct.
Yeah.
And then I helped with Charlie Hall and numerous other companies.
Yeah.
I had my own company, Water Products Research, and we built a lot of different systems for different people and private label them. And
Did you build a system for a guy in Alamogordo, New Mexico, by any chance? About 10, 12 years ago?
I don't believe so.
This was for a guy that I used to work with when I was at Boyle Engineering. And he had a contract with the city of Alamogordo to do some pilot testing.
I think I believe
Yeah,
I built one for him, but it didn't go there in the beginning. He used it for other places. So I'm
okay.
sure.
Okay.
I did like all the,
Yeah.
back then it was called toilet to tap stuff for San Diego. I built all those pilot systems
Oh, you did?
years ago for
Yeah,
Montgomery
yeah,
Watson, yeah.
Yeah, that's right.
And actually, I'm working now with the city, and it's called, in the, the potable reuse thing. And Mac actually built the RO.
We
but-
built the RO system,
Yeah.
for San
But
Diego.
now I'm working with Torre, running our membranes and hollow fibers in them, and I'm pretty much doing a lot of hollow fiber MBR stuff now.
Yeah, I worked on the toilet tap project with, I was at Boyle, we teamed with Malcolm Perney to do the preliminary design of that plant. So we used to have a monthly meeting out at the aquaculture facility there and find out what was going on with all the pilots.
Yeah.
And there was a French guy there who was with the, what's the name of that company that had a hollow fiber ultrafilter there that was made of cellulose acetate?
Aquasource.
Aquasource. Yeah, he was really upset because he thought that the filtration system wasn't being operated correctly. There was too much ferric salt being added, and it was screwing up his membrane. I remember that. He was typical Frenchman. He smoked about 2 packs of Gauloise an hour, and was very irate. That he thought it was an American plot to sabotage a French membrane, I think.
Yeah.
Well, I ran the 4 systems that were there with Sammer from Montgomery Watson back then.
Yeah, and Paul Gagliardo was there.
Yes,
right?
yeah.
Right.
And those things moved all over the place.
Yeah.
And that was 4-inch back then, but now, of course, a lot of stuff is 8-inch.
Yeah. Yeah.
I actually did the Orange County thing with Roga, or Fluid Systems, I guess, back in the 70s. I was on site there, building it, and then we started it up, and I was on one of the crews I was on the second shift. We had to watch it run for 2 weeks before they paid us, I guess, That's actually when Terry Smith first came on board. I think I was with Terry Smith, and we're just watching the control panel all night.
Yeah,
The good old days.
yeah, that was I'm not too sure they were that good.
That's when the end
sometimes,
caps were
but
all
they were the
flying
old
off,
days.
right?
Well, the thing of it is, speaking of evolution of membrane technology, if you will, and some of the development that has taken place, like I said before, fluid system was always in the forefront.
Mhm.
And it was within Dr. Seymour Kremen's group, the thought process started about going to fiberglass pressure tubes.
Right.
Yeah.
Yeah.
And
Yeah.
of course, Pete Darby and Rick Gleason, they were both very instrumental in doing that kind
Right.
of work.
Right. Yeah, and then they stopped building those as well.
Well, that was
Eventually.
a decision which was made, after we did Jeddah 4, the seawater project, with Jack Luce, myself, and Al Riedinger. We were the three leading project managers on that, if you will. But once that was finished, I think, they had made a decision that perhaps it is better to be a membrane company rather than membrane and systems company.
Right. Right. Right.
So eventually they got out of the system business.
And Film Tech never did want to be in the systems business.
That's right. But they wanted to buy Advanced Structures.
Huh?
They wanted to buy Pete Roberts' company, Advanced Structures.
Oh, they did?
Yes.
Ah, I didn't know
Because
that. Did you know
when I got was an extra $10 million for some raised capital, and I thought there are a lot of customers, and I wanted with the elements, the pressure vessels. So why not? We have money, why not buy the company? But what I've been told, Pete Roberts didn't want to sell it.
Yet. Not
So-
yet,
that?
anyhow.
Yeah, yeah.
So, but there was no thought at Film Tech to go into system business. No.
Right. And when you were there, even though the composite membrane was being used and developed by several companies, there was still a lot of cellulose acetate being made.
That's right.
And Film Tech never did make a cellulose acetate membrane.
That's correct, because they thought that polyamide was better. That's what John Cadott developed, so there was no reason to make CA membrane. And on the other hand, there were many other companies like Fluid Systems, Aeronautics, and other making CA membrane. So it is better to go with that,
Right.
the best membrane.
Right.
And of course, I remember there were conferences where we had one person, Dave Walker from England, person, you can say salespeople, go selling a product.
Dr. Dave Walker
Yeah.
eventually worked for Fluid Systems.
I remember
He
now.
did before, yes.
Yeah.
Then he went back to England and came back to Film Tech. And I remember that one conference, he said that polyamide will take over, CA will be gone, almost gone. And Seymour Kremen objected. He was very irate about that statement.
Were you there when they developed the nanofiltration membrane?
I was there when it was introduced. Of course, this was the membrane developed years before, but I was there when we made it commercial. And I was the person that came up with the name nanofiltration.
Oh, you were?
Yes, because we must have a name for it. And Roy Larsson, who was the VP marketing here, one of the founders, he thought we call it hybrid filtration. Because they had in Israel, they had some membrane, CA membrane, they bought 70 directional sodium chloride for, they called it hybrid filtration. And Roy thought, oh, I should call it hybrid filtration. But I said, no way, it's not a hybrid, it's a membrane, it's not a hybrid membrane. So I thought for a long time, month, and then Roy said, no, you might come up with a name here. The same day I said, that struck me. Nanofiltration was the right word for it. Like we have microfiltration, now to micron size pores. Now we have pore size about 1 nanometer, could be nanofiltration. And of course, I would prefer to call RONF be nanofiltration because there is so small difference in the pore size.
Yeah.
And there is really performance also, just a gradual.
One of the earliest applications of nanofiltration was in Florida, and the urban legend is that it was the brainchild of Paul Culler,
Mm.
who was the president of Basic Technologies.
Correct.
And he persuaded Fluid Systems to deliberately destroy a CA membrane to give him the characteristics he was looking
of the
for.
nanofiltration, right.
That's true?
I have heard that story. I'm not sure exactly how far that was.
One thing that always struck me as odd was that you would make a membrane and then semi-destroy it. Having done that, how could you predict how long it would actually last in that form?
Once you destroy it,
Yeah, well, you don't actually totally destroy it, but you modify it, let's say.
well, it would depend upon, what the final usage is. If you're just looking for partial salt rejection or certain type of quality, that would continue to work. CA, of course, had a property, which with time, it would get hydrolyzed, no
Right.
matter what you did,
Right.
So your salt passage would increase,
Right.
and basically, the rule of thumb was in 3 years it would double, so we called it 3-year life.
Right,
Of course, you need the higher pressure and the acid
Yeah.
injection,
right, right.
which was
And that was one of the, particularly on the municipal side, that was one of the great advantages of composite membranes.
Yeah.
Was that you could do away with the acid in most cases, not all
Correct.
cases, but in most cases you could do away with the acid, particularly when some of the more advanced scale inhibitors came along. You didn't need
Yeah, in
acid
the
at
old
all.
days, it was only EDTA, that's
Yeah,
all
that's
we
right.
knew and that's all
Right.
we tried, and sometimes
And
it worked
sodium
okay,
hex
and
yeah, sodium hex.
but basically whether it is CA membrane or polyamide membrane, it all depends upon the water chemistry and
Yep.
bicarbonate level.
Yep.
Because it's a concentration process, it's going to fall out, it's going to fall out on membrane.
That's right.
It doesn't care which membrane.
That's right.
So
It doesn't read the label as it goes by.
exactly. So
That's and of course nanofiltration has become a big market in Florida, particularly for
Yes.
not only for softening, but also for organics removal.
yes.
And you got a shallow groundwater that have high THM formation
THMs,
potential. It's been great.
Right.
It's been great. I remember going to a meeting it's a city council meeting at, I think it was Hollywood, Florida, many years ago. And Dave Furukawa was there. He was working for Film Tech at the time. And Paul Culler, I think. They were making a presentation to the city council about this new type of membrane so they could get rid of their lime softening plants and the lime sludge issues and all those other things. And I think that was the first time anybody had really publicly announced that this technology was available. I mean, the fluid systems, the Pheasant Walk and a couple of others, what was the one over in Pelican Bay, over in Naples? They were running with CA membrane. But nobody had really told the public at large that there was this new technology and they could replace their lime plants and get rid of the sludge issues and so on and so forth. It took another 7 or 8 years for that actually to catch on.
Yeah.
And
I think it took much longer time to catch on completely.
it took much longer to catch on completely. You're right,
I remember
Peter.
on conference that was an international water conference. It might have been 8 years ago or so. Was some presentation from a consultant from Bechtel company, a power plant they built there. And for 1 year, they were standing still. They couldn't get clean water. They had the lime treatment and this and that. They couldn't make good quality enough.
Right.
It took over a year before they could get it right. So I asked, why didn't they use NF in the first kind? He said, NF, this is 3,000 dpm plant. Have you ever, it was you thought much too big, and NF plant cannot handle 3,000 dpm. I was flabbergasted somewhat. So even in the beginning 2000, still some people didn't believe in NF for water treatment.
Oh, no, they didn't. And there were some, I mean, in Philco Degermont, or in Philco at the time, was before it was bought by Degermont, probably supplied 90% of the lime softening plants in the state of Florida. So when NF started to make an inroads, I got a call from the guy in Florida who represented in Philco, and he came over with Dave Grunow. I don't know if you remember
Yes,
Dave Grunow, and, who was a sailing buddy. They sailed together. So they came over to my house in Fort Myers and said, what are you trying to put us out of business? This was George talking, not Dave. I mean, Dave was in the membrane business. So. And I said, no, but you should really talk to Philco about building NF plants. It's a logical succession to what they're doing. So we all trooped up to Richmond and went and talked to those people, and they all thought it was very interesting. We spent a whole day discussing it, and they said, the only problem is that we cannot compete price-wise with the OEMs in Florida. So there's no way we would ever win a bid. And so they tried to sell lime softening systems, and every year there were less sold. Finally, George packed up and said, "That's it. I'm going sailing," and he did.
That's one point of view, But what my experience has been that anytime you have a new technology, there is a certain amount of market resistance, that comes with it.
Right.
It takes a lot longer to educate people, or let's say the market area. Because if the technology is ahead of the market, that technology is not going too far.
Right.
You have to prepare the market, so that they can accept that technology. And I think, this is one great lesson that we have learned over the last 40 years, as to how to prepare market, so they can accept your new technology or new findings.
Right.
It's a very important aspect.
And when you and Kurt were building systems, fluid systems, and big plants, like 500,000 gallons a day and that kind of thing, did you ever expect that in your lifetime you'd see 100 million gallon a day seawater RO plant?
Not at all. Not at all. When we were building them for the palaces in Saudi Arabia, people's houses, and
well, we did see multi-million gallon per day plant. We built 3.2 million gallons a day, first seawater RO project, other than Malta, which was the biggest at that time. But 100 million would be a little bit stretching, Perhaps, our vision was not that far. We could only think. Actually, I started changing my thinking rather than just simply desalination or water use, taking membrane technology more into as a separation technology in chemical processes.
Right.
Because I saw, during this period, I saw that there was a great need in chemical process industry, for recovering byproduct chemicals. And water would just be simply a byproduct, Chemical had, a lot more value.
A lot more value.
So I started concentrating more and more on separation, membrane technology as a separation technology rather than desalination technology. And I think, now you see wide variety of application in chemical industry.
Yeah. Hob McPherson actually was telling us a story of a system that he did that was in a copper reclamation facility. They took scrap copper and dissolved it up, then plated it out into very pure copper ingots. And they would take the copper sulfate solution, the used solution, and concentrate it, put the copper sulfate back into the bath, and take the water at the end as a rinse.
Rinse water.
Rinse water.
So double
again.
use.
And that's what an elegant way of treating the problem.
Somewhat similar to what we do.
Yeah.
I did a chemical separation process for lead acetate. Our buttons are made out of lead acetate. So what they do is, after whatever their gelling process is, all that wastewater is left, contains somewhere about 0.5% to about 2% of lead acetate. So actually, Kirk built that plant for me. I sent it to India, and it's now, I believe, 14 or 15 years. That plant is still working.
Still running?
Still working. And the beauty of it is, that payoff period was something like 15 months. So
Yeah,
the industry, the people were very happy,
That's
that,
right.
the plant
right.
paid off, and plus all this recovery of pure water as well as lead acetate.
Right, right.
It's a win-win situation.
And speaking of India, they have they've been embracing the technology for some time also. And
Well,
it's,
actually, I was, although I left fluid system in late 70s, but I was always retained as a consultant to fluid system to develop Indian market. And later on, I signed up with hydronautics. So most of the big, larger plants that you see in India today, whether they are brackish water or seawater desalination or textile industry, they're basically with hydronautics membrane.
yeah, they had
Yeah.
a partnership with Ion Exchange India.
That partnership got sort of dissolved, long time ago. In '97, when I came aboard, at Hydronautics, basically the idea was to educate the market and, try to promote Hydronautics name.
Right,
So
right. I think as I visited there a couple of times, maybe 3 times, they had quite recently, I think, entered into this joint venture with Ion Exchange. And if my memory serves me correctly, the membrane manufacturing equipment that they sent to India, Jim Bartlett had bought from Envirogenics and sent out there.
it was cellulose acetate,
Cellulose acetate, absolutely.
It was never polyamide
No, no,
technology.
never was.
And we as marketing arm, then basically said, that cellulose acetate technology was not suited for a hot country, or let's say, India is basically, the atmospheric temperatures are very, very high, for most of the year, and even the water temperature is kind of warm, lukewarm in 90 degrees or so. And of course, with cellulose acetate, the hydrolysis problem gets elevated, or enhanced, with the high
Right.
temperature. So that technology was really not well suited.
Right. Right. The one of the questions I've been asking everybody is, having chosen this career in membrane technology, if you were graduating from college and you were considering your future, would you do it again? Kurt?
I think I would, definitely. Yes.
It's been fun.
Maybe I'll do it my next career. My next
Yeah.
I still don't know what I want to do yet.
Mac, how about you?
I tell you, my advisor at University of Missouri, when I first got the job offer from Fairbanks Morse to work in water treatment and wastewater type of situation, I went to him and I told him, that I have this 2-3 different offers, and being a chemical engineer, I wanted to get either in petrochemical industry or plastics industry. And that's where, the jobs were, and they were quite lucrative as compared to what Fairbanks Morse was giving me.
Right.
He said, no, Mac, you stick into this industry. And he was so prophetic, I think. In my estimate, water industry is a very honest profession. It gives you a lot of satisfaction, and it's a good profession.
Yeah.
It doesn't make you overnight rich like an IT industry will, but
Well,
nevertheless,
but
you're
you can
never
always
short
hope.
of work.
You can always hope.
It's always interesting.
Peter, how about you?
Yes, when I started with membranes, I was quite certain this would be expanding field. So there no problem to find a job in
Right.
the future. And it has been so. And if people start now, those who graduate from college today, if they like it, water I like water very much. I like water in the woods. I like waterfalls. I just like water. If they do the same thing, go into water because it will be there forever.
Right.
People need water. There's no doubt. But if you don't like that water, of course you do something else. So it's do something you enjoy doing. That's the main thing.
Well, my wife has always said that in spite of the fact that I've never become very rich, that I actually chose a profession which would probably make sure that I was always employed, because everybody always needs water.
That's what I was saying. There's never a dull moment.
Never
in
a
this
dull
industry.
moment.
That's right.
And you're right. There's a lot of satisfaction in
Very
completing a project, and giving some people. I remember a story. This was a plant Hydronautics built many years ago in a small town called Los Animas in Colorado.
Mm-hmm. Yep.
And it's about 2,500 TDS water. It's almost all calcium sulfate. And I wasn't there. This was Mike Humphreys told me this story. Actually, I think Paul Laverty was there too, and he told me the story as well. But when they had the dedication of the plant, several of the local leaders came and thanked them profusely for building this plant. And they said, well, why are you thanking us? They said, well, because finally we can cook beans properly. And I thought, yes, what a great sentiment. For years you've been struggling cooking your beans, and now all of a sudden you got good water and you can do it. That's it. Thank you very much for coming. Appreciate it. And if you can think of anybody else that Doug is determined to make me do this for the next 20 or 30 years, I think. If you can think of anybody else that we should be interviewing that you feel had a significant impact on the beginnings of the industry, please let Doug know or myself. And
Great.
again, thank you for
Okay.
coming.
Thank
It's
you.
been a
Thank you.
pleasure.
Thank you for
Peter?
inviting
Ian.
us. Ian?
Good.
Nice